Okay, I want to show some composition of functions and combinations of functions. I have the new notation here. And again, this notation in the old notation means f of x plus g of x. And here's an example. If this is the f of x function and this is the g of x, f plus g of x means to do 2x minus 3 plus x squared minus x. At this point, you would combine like terms, if there are any, x squared plus 2x minus 4. Now, if I had f plus g, okay, so now if I wanted to do f plus g of 3, I just follow the pattern I did for f plus g of x and plug in 3. So I would get 3 squared plus 2 times 3 minus 4, which is 9 plus 6 minus 4, which would be 11, and that would be the answer. Okay, let's do an example of a combination of a function with subtraction. So, and again, the old way that we would write this would be f of x minus g of x, but we're going to get used to the new notation. So f minus g of x means to do, I'm going to use brackets for the first step, 2x minus 3 minus x squared minus 1. The important part here is to make sure you distribute that minus sign. So 2x minus 3 minus x squared plus 1, and then combine like terms, negative x squared plus 2x minus 2. That's the answer. And again, if I wanted f minus g of 3 for this, I would plug in the 3. So I would do equals minus 3 squared plus 2 times 3 minus 2. Can you see that? And then my final answer for that one, 3 squared is 9, plus 6 minus 2 is 12. All right, on this combination, it's a multiplication of a function, or f of x times g of x in the old notation. So fg of x means to take 2x minus 3 times x squared minus 1. Multiply that out. So 2x times x squared, 2x to the third, minus 2x minus 3x squared plus 3. Again, combine like terms, and you get negative, you get 2x to the third minus 3x squared minus 2x plus 3, no like terms. And then, again, if I wanted to do fg of 3, right, I would just plug in the 3. So 2 times 3 to the third minus 3 times 3 squared minus 2 times 3 plus 3. We've got 27 times 2, 54, minus 3 squared is 9 times 3, 27, minus 6 plus 3. And I'll leave the figuring of the last part of that for you. Okay, combination of functions with division, and this really means f of x over g of x. This one's a little bit tricky. So again, we're doing the division, which is f over g of x. It is tricky, so be careful. 2x minus 3 over x squared minus 1. When you have a fraction, you have to be careful of restrictions or values that make the bottom of the fraction 0. And in this one, if I take the bottom of the fraction and set it equal to 0 and solve it, I can factor to solve x minus 1, x plus 1. So x not equal to 1, x not equal to minus 1. Those are the restrictions on that variable. So any real numbers work except for 1 and minus 1. Make sure if you have quotients that you show the restriction. All right, last but not least, composition of functions. F of g of x. In this one, it means to take the function g and put it in the function of f. And we used old notation for this. It would be f of g of x, like that. But we're going to use the new notation, so f of g for x means to take this f of x function, and where the x is, I'm going to put a parenthesis because the g of x function goes in there. So x squared minus 1. Now I'm going to simplify that a little bit. 2x squared, my marker's running out here. All right, 2x squared minus 1 minus 3. Can you read that? Let's fix it a little bit. 2x squared. So that becomes 2x squared minus 2 minus 3. Combine like terms, 2x squared minus 5. Now, again, if I had to plug a 3 in there, you just do 2 times 3 squared minus 5. 3 squared is 9, times 2 is 18, minus 5, and you can figure the rest. You should be okay with this assignment now. Good luck.